My pleasure is to introduce the first speaker, who is CTO of Saab Finland. Saab is one of the partners of FCAI. We have a wide community of companies, and Petteri here now is giving us an industrial application viewpoint to these questions. I'm ending my screen share. And Petteri, can you share your screen?
I hope so.
Looks good. Great.
All right.
I'm turning off my own video.
Okay. All right. So hopefully you can see my slides. And thank you, Arno. I believe I was invited to come to talk here because we are running quite ambitious research project at Aalto, at FCAI at the moment. Having said that, I'm not an expert in AI, but I realize that there's plenty of experts here, so I'm sure that we can manage this event well. I did title my presentation AI for surveillance, so a little bit narrow it down. So surveillance is the area where Saab is active in Finland, both in a research domain and also in R&D. So I try to, instead of digging deep into the technology, I try to explain what is the role of AI in the defense sector, and also what we at Saab, how we have started to address AI and what are the first applications. So my key points are that since defense sector is specific in that sense that we require extremely high trust in all aspects. And because of that, then the AI has been taken up slowly and quite cautiously. But at the same time, then there's a very clear vision that eventually AI will completely disrupt the defense sector, and I will dig a little bit deeper in this area shortly. Then I will spend most of my time talking about this surveillance area, where there are clear areas where AI brings significant benefit, and that's also where our Aalto activity is focusing on. And then finally, I want to show that there are AI and big data and data associations can introduce also completely new products for this type of situational awareness. And I'll talk about a new product called Mimer's Bell shortly. I'm not going to give any kind of company presentation, but I still wanted to show one slide about our quite broad portfolio that includes different type of vehicles, submarines, aircrafts, fighters, and airborne early warning aircrafts, different type of sensors, radars, and signal intelligence receivers, and command and control centers for military purposes, and also flight control centers for civil aviation. And I'm showing this because it's already from this very broad portfolio of different products and systems, it's easy to see that AI will have an impact on all of them. It can well be the kind of supporting the decision making that many of these systems do, or it can be helping the autonomous operation of novel vehicles, for example. Then more broadly about the defense sector, there's a very interesting report out. I think it was published 2 weeks ago by US National Security Commission, And in that report, they discussed how AI, what kind of impact AI will have in the defense sector. And it's very interesting reading, at least most of the 750 pages of it. But the clear conclusion there is that AI will transform the way war is conducted in future, in all domains, undersea space, cyberspace, and so on. And it will impact the decision-making, strategic decision-making, and different type of operational concepts and planning and tactics and so on. And it goes even to so far as to say that the key performance parameters such as speed, tempo, and scale, that they will be defined by the quality of the AI algorithms and methods. So it's a kind of hinting that the military dominance in future will be defined by AI technologies. It also then being a US report, it's also suggesting that US should clearly step up the investment levels in AI to maintain that dominance. In the same report, it also paints the picture of the dark side, that in addition to building new capabilities and improving the performance, new things appear, new threats. That AI is very, very good in boosting the reach and range of known threats like malware and disinformation. It can create new threat phenomena like deep fakes and micro-targeting that we have recently read a lot. And then, at least for me, it was interesting to see that the vision is that the AI stacks themselves will be kind of attacked, or there's a threat to attack them, like training data manipulation and data lake poisoning and this type of elements. So as with all, I guess, all new technologies, there's a benefit, but there is also a possibility to use it for bad purposes. Okay, so the vision is really big and disruptive. But then what we are seeing as the early steps of using AI in defense sector, those are quite cautious. Typically in the areas where for example, that the results of AI can be proven with other methods, so that the trust is built by that means, or in the areas where the proof of the results is not necessary, or where we can clearly take the risk that the result might be wrong. And this type of applications typically appear in, for example, in simulation environments where we are working on some kind of operational analysis to see how things might happen in certain scenario. And AI can be extremely powerful in helping there. So big vision, cautious steps in the defense sector. Then I will jump into this surveillance area, and there we can see at least three types of applications for AI. And the first one is to look at some kind of function level enhancement for the existing sensor products. Sensor products being typically radars, signal intelligence receivers, and so on. And secondly, a kind of sensor that the whole products could be enhanced, new capabilities for the products, or then there could be a completely new AI triggered products like the Mimers well that I will briefly touch also in this presentation. Okay, if you talk about the function enhancements, we are typically talking about signal processing, and signal processing is a kind of pattern recognition, and pattern recognition happens to be, I've been told, one of the areas where AI and deep learning is at its strongest. So there's as a starting point, there's a good match in starting to look at how can we do the signal processing with deep learning. And this is exactly where the AI activities in Saab surveillance started, to start replacing the existing traditional DSP algorithms with different deep learning or other machine learning algorithms. And that proved to be a very successful project. We were able to get the performance we wanted. So the main value of this was really the validation that the methodologies work in our applications as well. Not real performance benefit in here because the traditional DSP algorithms in this type of applications are very optimized. So no significant performance boost, but some kind of scaling benefit in that sense that whenever we need to do new sensors, we might be able to apply these AI-based algorithms more rapidly than the traditional ones. But the main really value was in the validation. But then more interesting is to look at the product enhancements, and in particular in the area of signal intelligence. How it happens today is that, let's say today, is that we are basically scanning the skies, trying to figure out some signals there, and when we identify a signal, we then detect it and record it, the waveform, and then we take a threat catalog and look at from the catalog that, okay, what might this signal be, and then make a decision what to do with it. For example, if it's a hostile signal, we might want to jam it or something like that. But this becomes very difficult in a kind of with new type of radars where the signals are much more agile, jumping around, trying to hide themselves from exactly this type of actions. And they are using, we are talking about cognitive radars and using learning algorithms at that end. And so then there's no way we can use any kind of threat libraries or catalogs to look at those signals. Instead, it's almost like the AI is the only way to try to learn how they behave and try to make a decision and categorization based on that learning that the AI algorithm is able to achieve. So it becomes this type of cat and mouse game that the other one is trying to hide and the other one is trying to find it, and the one with the more powerful algorithm will be the winner of this. So the electronic warfare develops into this type of warfare of algorithms. And there are some key enablers for this type of technology that wideband digital channel as receivers have become possible, meaning that we are able to record basically all the signals in a hemisphere with very wide bandwidth that requires then huge amount of computational power that is starting to be there, and then we need good software as well, and even that is readily available. To be able to show some real data, then there's a kind of example here that where we are applying deep learning for this type of time frequency spectrogram. And in this example, there's radar and communication signals that the same sensor is seeing, and deep learning is here as a black box, so data goes in and decisions come out, but the process in between is somewhat opaque for us. And here's the data, so we can see there a radar signal with the varying frequency, so the y-axis is the frequency bins and x-axis is the time samples. So there's a varying signal radar and one fixed frequency radar, and then a communication signal. And without going into details of the picture, the third version is the prediction that the deep learning algorithm gave, and it's a very good prediction. So we are able to utilize the methodologies in these applications. But very important part of that is to then also create some kind of understanding of the confidence, that how certain we are that this is the right answer. And there's a confidence map, the lowest version of the data. And that's exactly the area where we are working on research with Aalto University, that deep learning models kind of inherently don't contain any reliable uncertainty information, and we are trying to build that in the process. Doctoral student Lassi Meronen is working on that, so he can share more information if you are interested. There was a very good conference paper published on this recently, and yeah. Okay, and then the final topic that I have with my time slot, I hope I have time still, is to talk about that AI can also be used for completely new type of innovative products, and this Mimers Well is an example of such. What is Mimers Well? It's basically a big data platform capable of storing massive amounts of all kinds of data, sensor data, video data, satellite images, and so it's agnostic to what is the data. You can add anything, and then it's a high performance computation platform which then is used for training the AI, and it's a microservice platform in that sense that it can serve other applications and products, easily integrated in many command and control systems, for example. Data fusion, it likely could be used for completely different type of applications than what we are talking about in the defense and public security sectors, built on open source projects. And what Mimers Well then does is that it creates awareness, situational awareness, by combining different data sources. So basically data fusion, high quality data fusion. But in addition to this type of snapshot data fusion, it also contains the time series information, which that can show the direction of different events. For example, in the middle bottom picture shows this type of heat map of some region where some new buildings have been happening during the last weeks. So based on satellite images. But then when we have the huge amount of data for situational awareness and the time series, so that's exactly an excellent material for training the AI to build predictions that what happens next, so that there's some kind of intent of being built based on the material or on the data. And that then it becomes really interesting to be able to learn that what might happen next. So as the data volume grows, then it becomes more valuable, and these data associations reveal really new insights and connections. And when we do this for a long time period, we can also probably identify same targets over again and again, and in that way build the digital fingerprints of different, for example, vehicles. A lot of different data at the moment available, but this is a new product, and it might well find applications in completely different areas. So very generic in that sense. Okay, this is my last slide. So repeating the key points. So in defense sector, there's a requirement for high trust, and because of that, then AI is taking up slowly and cautiously. But then we have a very radical vision that AI will completely disrupt the defense sector. In the surveillance area, AI can significantly assist, especially in this evolving signal environment, and this is an area where Saab in Finland is active. And then that final point here is that AI, big data, and that data associations can introduce completely new type of products like this miners well. All right, so that finalizes my presentation.